Hi folks, so this continues our Flux developer environments tutorial. We are moving from flux-core and flux-sched, which were both VS Code based. One had auto tools, one had CMake, into the Flux operator where I'm going to be running things on my local machine, still in VS Code. Let's get started. Let's jump over to the Flux operator. I think I opened a VS Code for it. Here, I did. So the Flux operator is a little bit different. So let's open a terminal. Because we are not going to use a container, so maybe this is not folks' ideal thing, but I like to run stuff locally, which means I have Go locally. I usually have a not totally bleeding edge, but not like super old version. So right now I'm running 1.22. So I have made things easy for myself, but I guess also for you too. So let's see, test deploy. There's two commands we're going to be using. So just to kind of step back, the Flux operator runs in Kubernetes. An operator means that it is a container that can have, for example, a controller in it. It can also have webhooks in it. So the Flux operator primarily is going to be accepting custom resource definitions, which are YAML files that tell it how to deploy a MiniCluster. These are the Kubernetes objects that you need to make to deploy Flux in Kubernetes. It's actually very simple when you think of it like that. So when you're developing for the Flux operator, you want to use kind, which is Kubernetes and Docker. So that's another, see, install kind. You've probably seen this before. So this is kind. It has I really like this logo. It's like a little like ship in a bottle. So you can install it in many different ways. Once you do install it, you will have an executable named kind. So what I usually do is I do kind create cluster, and then the config, I keep one right in here alongside the examples called kind config. So you just give it that. You can add more nodes if you want, but you don't really need to for just kind of playing around with the Flux operator. So while that is coming up, I'll show you where all of the examples are. Well, I guess I won't because it just came up and it's really fast. So what I was going to show you here is that normally there's like a bunch of different make commands, like make manifest, make that you would kind of build your thing locally. And it's really complicated. I wanted a command to basically build and push a development container and then apply it to my cluster because, side note, when I'm developing the Flux operator, I am making a change and deploying it. I'm doing that a million times, and that needs to be fast. Otherwise, you will just accomplish nothing. And so once you have your cluster, to just build and push an image to some test image URI that you'd have, you would do make test deploy. Note in the Makefile, there's dev image. So you'd want to do like dev image equals GitHub and my org and my repo and a tag. We're going to just use the default test tag that I have. So I'm just going to do make test deploy, but I'm also going to add recreate, which is another tag I made. So recreate here, it runs test deploy. So it's going to do a Docker build, a Docker push. And then this is what you typically see with one of these operators is that you're going to use customize to build your manifests and then output it into a YAML file. And this dev one is specific because it's targeting that special image. So let's get that going. So this as soon as you just clone it, is basically going to prepare a little bin of all the executables that you need. There it are. So we have install customize, we have controller gen and customize, of course. So while that is building, let me show you the examples. The examples directory is really nice because it has a lot of kind of getting started stuff. Specifically in tests, there is a LAMMPS one that I think is a good HPC getting started because everyone knows LAMMPS. So some things to point out. These are our containers. You can actually have more than one container, but for the very vanilla case, we're just going to use LAMMPS. A working directory, a command. You don't actually need tasks here, where we can just delete it. Logging quiet means that you're not going to see output from Flux. And so we could remove that if we want. And the size is going to be the number of nodes that we have. So in a real Kubernetes cluster, these would be actual nodes. Here, it's just going to be a container because obviously my machine is just like one computer in front of me. It is not several nodes. So once the Flux operator is built and installed, we are going to do kubectl. So that's another contentious word. People say it in different ways. I say kubectl, apply F, examples, tests, lamps, MiniCluster. We're not going to do that yet because we haven't installed the Flux operator, but it's installing. I might fast forward in the tutorial. Let's check on our test though, shall we? Hey tests, how you doing? Okay, 100. This is flux-sched, 100% pass. Took 330 seconds. Again, there are ways to speed that up. I wasn't super interested. If you're interested, all of the tests are basically these little T files in the T folder. And I'm not going to go through this, but if you look at it, it's fairly intuitive. We should probably have another tutorial that talks about tests. Nobody likes writing tests. Nobody wants that tutorial, Vanessa, and it's not needed, right? Okay, let's quickly check on flux-core. Flux-core is still running. So yeah, I probably needed to give it more processes or something, but that's fine. I expected this one to take a long time. There's a lot of tests for the core of software that's running on El Capitan. I'm actually very happy there's a lot of tests because wouldn't you be worried if there were not, like, right? Okay, so we just deployed the operator. So when you want to look at logs for the operator, you need to look in the operator namespace like this. If you add F, it will hang. Oh, just kidding, it's still creating. So let's see, we'll do get pods in that namespace to see if it's being there yet. Operating system. Oh, good. Did you get your pods? Did you get your pods? Okay, it's running. So now we can look at logs. So this is what I am working output looks like, that it started and ready to go. So now we can do that kubectl apply command to create the LAMMPS MiniCluster. And at this point, this is in the default namespace. You can just do kubectl get pods, watch. So this LAMMPS container is pretty chunky. So probably I will fast forward the tutorial. So we don't have to wait. So you don't have to wait. I will wait. I promise I'm a good waiter. While it is waiting, let me actually tell you what's going on. So during the init, the way that the Flux operator works is that you'll notice that for this container, there's no Flux in that container. It is just an Ubuntu base with LAMMPS installed, some MPI. And so what we actually do, we have an init container that is preparing a Flux view. The Flux view is actually going to be mounted to all the containers, before they run. It's going to then take an isolated view and install a Flux and basically add it via an empty directory to this LAMMPS container, and then it's going to go away. So the init container goes away, and what it leaves you with is sort of an injected Flux into your application container. So your application container starts up, and there's Flux inside of it, even though you didn't have to install Flux. And the Flux operator was not originally like this. The very first version that I made required the user, you, to install Flux, and I didn't like that design. Yeah, that was a bad design. So once the pod is initting, it goes to initializing. This is actually when the LAMMPS container is pulling, which is why it takes quite a bit longer to complete that step. Okay, we're running. So when something's running, you do flux sample 0. So flux sample 0 is the lead broker. That's where we're going to see the logs. Oh, we caught it. There's LAMMPS doing its LAMMPSy business. Go LAMMPS, go LAMMPS, go, 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 go. It's your birthday. Actually, I don't know why people say that, but I know people say it, so I'm just mimicking them. Okay. 10 steps, 10 dangerous build not checked, 23 seconds. Okay, so after you do that, the pods go into completed state. And so this is just sort of a technical, the pods are actually done. And the reason that the job leaves this completed is sort of a courtesy to the user. It's so you can get your logs, you can check them. What we're actually going to do is we're going to delete it. So a MiniCluster in itself is an object in Kubernetes. So you can just delete the whole MiniCluster. So delete MiniClusters, flux sample. By the way, I have auto completion enabled for my kubectl, which is why I can just press tab and all these things are auto completing. So after it's deleted, boom. Once they're completed, it'll delete immediately. So let's actually make some changes here. let's remove the logging quiet and let's set interactive to true. So this is the case where you're like, you know what? I want to shell into my cluster like an actual HPC cluster and do cool stuff. That's something we do, right? So we're gonna again kubectl, apply F, there's examples, test LAMMPS MiniCluster, get the pods, watching the pods. So this container is pulled now. So now what you'll see is basically the time to prepare everything. So a init, pod initializing through running. The init still takes some time because it's moving a pretty big, Flux is not a tiny thing. So 17 seconds, so 18 seconds, not terrible, not super speedy. Okay, so now though, if we look at the log, I'll show you the logs because I removed the logging. I think it's interesting to see Flux starting. So I very purposely made these very verbose so that you can see everything that's going on, the mode that it's running in, the submit. You see the workers joining. You see that now the quorum is full. Ready for duty, Captain. Reporting for duty. So we are going to shell inside. So when you shell inside a pod, you're using kubectl exec, IT for interactive terminal, just like Docker. We're going to target that lead broker again, and then we're going to use bash. So once we're in, we actually aren't connected to the Flux instance. So we have to do that. And I've made this very easy because in mount flux view, there is in mount flux, there is a file called flux view. I source this, and now I can do flux proxy to the Flux socket in bash. And so the Flux socket is basically the connection URI. So you'll see that here, this local URI is saying like, I want to connect to actually a local socket in the file system. That is this path here. Flux has other formats of sockets. So for example, SSH. And so we are now connected to our Flux instance. So now is when we can do Flux resource list and there's our cluster. So note that we're in the LAMMPS directory. Let's run LAMMPS, shall we? So let's copy paste this. So we need to add the Flux. So let's do Flux run N2, and let's actually make sure we have LAMMPS on the path. Yep, so Flux run N2, and we'll run LAMMPS. And that should run LAMMPS. So this is the environment where you'd like bring up your cluster, you would shell in, and I've said this before, but we're going to have tutorials where we just actually start in a cluster, and then I'm going to show you all the really cool tricks that I have. There's such cool stuff you can do for interacting with your jobs that I can't even. Let's see, Flux job info, Flux job last, R, type that into JQ. Have installed JQ. Okay, so we're not going to pipe that into JQ. You can look at the job spec. Anyway, I will show you all these things. What I basically wanted to show you today is how to get the development environment for these 3 projects. So to summarize, for the Flux operator, you clone it. You will need Go installed. I highly recommend VS Code because of the auto completion ability. By the way, in here, under package Flux is where you're going to find most of the logic to interact with Flux, all the templates that are generated when the cluster starts up. Actually, let me show you that really quickly. All of the assets for the Flux operator, like the entry point, are here under Flux operator. So there's the curve certificate, there's the Flux init file, there's a wait. That's basically the entry point. If you're interested, in the repository, you'll find a lot of that logic under package. The controller bits are under controllers Flux. So that's the structure. So to step back, clone the Flux operator, make, test, deploy, recreate. After you've created the kind cluster, then you will have your nodes. This is actually just a control plane. This is done by way of this kind config. You can customize this to add more Fox nodes. You don't have to. And then in the examples is where you can find all these different kinds of examples for running things. And so your workflow would be like to change something in the source code, make test deploy, we'll actually delete an old deployment and recreate it. And then you apply something and you test it out. And you keep doing that a million times until it's exactly how you want. And that's basically it. Shall we check out those flux core tests? They're still running. All right, folks, so that's the tutorial for today. This is just a very introductory developer tutorial for flux-core, flux-sched, and the Flux Operator, which is the one that I know, which is why we're biased heavily towards that. We will have future tutorials with actual developers from those projects. So something to look forward to. Anyway, thanks for stopping by. Talk to you next time. Bye.